Here we have 31, problem number 31. We have 3 kilogram object, has velocity, gives in terms of the vector, meter per second. Now, what is kinetic energy at this moment in part A? And in part B, we have to find what is the net work done on the object if its velocity changes to 8I plus 4J meter per second. Now, let's start then. The first of all, what we have, the given values is the mass is given, which is 3 kilogram. Then the velocity vector is given, which is 6 I vector minus 2 J vector meter per second. Now, first of all, we have to find the kinetic energy at this moment. So kinetic energy has a formula, which is mv squared over 2. Now, since we want to find a velocity, the magnitude of the velocity, then simply we have to use the Pythagorean theorem, which is 6 squared plus minus 2 squared. Okay, so if you do calculation, we should get that 6 squared plus 2 squared, which is give you, okay, plus 2 squared, which should give you under root of 40, right? So then we have to plug the numbers. Mass is equal to 3 kilogram and velocity is 40 squared divided by 2. If you do calculation, then you will get that 40 multiplied by 3 divided by 2, which should give you 60 joules. Okay, now this is a part A. And a part B, in part B, when the final velocity is equal to 8 I vector plus 4 J vector, we have to find the net work done on the object. So net work done on the object is equal change in kinetic energy, which means kinetic energy final minus kinetic energy initial. So this is our final. First of all, let's find what is a kinetic energy final, which is the same formula, mv final squared over 2. Now the mass is given 3 kilogram. Now that we have to find the magnitude of the velocity, which is v final squared, is equal to is given like 8 squared plus 4 squared, right? So if you do calculation, 8 squared plus 4 squared will give you 80. Okay, so if you plug the numbers here, 80 squared divided by 2, so you should get that divided by 2 multiplied to the 3, you will get 120 joules. Okay, then finally you just have to find the net work, which is a change in kinetic energy, which is equal to 120 joules minus 60 joules, which gives you 60 joules. Okay.